Hello children, in this video I'm going to explain question number 4 and 5 from 1.1 exercise. Use division algorithm to show the cube of any positive integer is of the form 9m, 9m plus 1, 9m plus 8. So we have to use the division algorithm, Euclid's division lemma, and we need to show that any cube of integer should be in the form of these three only. That means any one integer you take and do the cube of it. So you will get always the forms are 9m, 9m plus 1 or 9m plus 8, one of them. Okay. So let's put up the solution on the board. Question number 4, right? 4. Yeah. So let same steps A be any positive integer, and B is equal to 3. See here in the before sum we have taken B is equal to 6. As it is in the form of BQ plus 1, B is equal to 6 we have taken blindly. Even in the third sum we have taken B is equal to 3. Here also 3P or 3P plus 1. But here B is equal to, why we are taking a 3 instead of 9 means 9 factor is a 3. If we take a B value as a 9, the remainder should be less than the divisor, right? So we will get a 9 cases, 0, 1, 2, 3, 4, 5, 6, 7, 8. It will be very lengthy to show and show this problem. It is just 4 marks problem. So you can take the 9 factor as a 3. So I'm taking B value as a here 3 only. By division algorithm or Euclid's division lemma, A is equal to BQ plus R. We get A is equal to 3Q plus R. Here R value is in between 0 and more than less than or equal to 0 or less than 3. It should be less than the divisor. Q is quotient, R is remainder here. So what is R values? We may get a 0 remainder as 0 or 1 or 2. Less than 3 means up to 2. So just 3 cases. With the 3 cases, we can end up this problem. Okay. First one, if R is equal to 0. So A is equal to 3Q plus 0. What they said in the problem? Cube of any positive integer. So we need to do the cube. So A cube is equal to what? 3Q plus 0 is 3Q only, no? 3Q whole cube. Okay. So I'm going to show this 9, either it is in the 9m or 9m plus 1 or 9m plus 8. So our common factor is what? 9. Okay. So actually this is 3 cube means how much? 3 3 is a 9, 9 3 is a 27 cube, q cube. But we have to show 9m or 9m plus 1 or 9m plus 8. So 9 is going to be our common factor. So let us take 9 as a common. So if we take a 9 as a common, how many times it divides 27? 9 3 is a 27. So 3 times. 3 q cube. So this is like 9m, right? Here m value is what? 3q cube. It is in the 9m form. Next, we go to R is equal to 1. So A is equal to 3Q plus 1. So A cube is equal to what? 3Q plus 1 whole cube. How is this? This is like A plus B whole cube formula, right? So I'm putting the formula here. What is A plus B whole cube formula? a cube plus 3a square b plus 3ab square plus b cube. This is the formula. Okay. So we will expand this in this formula. So a cube, 3q whole cube, 3a square b, 3 into dot I am putting into it is nothing but a square, 3q whole square, b is 1 plus 3ab square, 3, a is again 3q, b square is 1 square. Okay, plus b cube. B cube is simply 1 cube. So 3 3 is a 9, 9 3 is a 27, 9 cube plus again 3 square is 9, 9 3 is a 27, 27 1 is a 27, 27 q square ma. Q square here plus 3 3 is a 9, 1 square is 1 only. So 9q plus 1 cube is 1 only. So always our common factor should be 9 only. Okay, because we have to show in the form of 9m or 9m plus 1 or 9m plus 8. So 9. 9 3 is a 27. 3q cube plus 3q square plus 9 went off, right? So q only left plus 1. So this can be written as 9m plus 1. Here, what is m value? M is equal to, in the place of m, this should be there, right? 3q cube plus 3q square plus q. Now we have one more case here. If r value is equal to 2. So a is equal to 3q plus 2. Then what about a cube? A cube is equal to 3q plus 2 whole cube. So again we need to split it in a plus b whole cube formula. A cube, 3q whole cube, 3a square b, 3 into a square, 3q whole square, b is 2, plus 3ab square, 3 into 3q into b square is 2 square, plus b cube, 2 cube. So this is 3 3 is a 9, 9 3 is a 27 q cube, plus again 9 3 is a 27, 27 2 is a 54 q square, plus 2 square is 4, 4 3 is a 12, 12 3 is a 36. 6 cube plus 2 cube is 8. Always our common factor is 9. So if we take up the 9 outside, 9 3 is a 27. 3 times 3q cube. How many times 9 goes in 54? 6 times 6q square. And in 36, 4 times 4q plus 8. Yeah, this is nothing but 9m plus 8. This is our required form, one of the. So here m is equal to 3q cube plus 6q square plus 4q. Okay. So if we observe the three cases, if it is 0, we got a 9m. If it is r value is a 1, we got 9m plus 1. R value is a 2, we got a 9m plus 8. So cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. See, I'll make you understand by examples. First, we will conclude this sum with the statement. Hence, cube of any positive integer is of the form 9m, 9m plus 1, 9m plus 8. So this is how we can solve. I told the example we'll see. For example, 3 cube. 3 cube is what? 27. So 27 means I can write 9 3 is 27, 0 is remainder. Another positive integer cube you do. 4 cube. 64, right? So I can write 9 7 63 plus 1. So this is 9m plus 1, right? This is like 9m. So any positive integer you take and make it as a cube, you can make out, you can write that in the form of 9m, 9m plus 1, 9m plus 8. Okay. Let's see another sum, fifth question. Show that one and only one out of n, n plus 2 or n plus 4 is divisible by 3, where n is any positive integer. Always we have taken a is a positive integer, little variation. N is positive integer here. If we take n is a positive integer, we need to show only one out of these three, n plus 2, n plus 4, only one number, one only, one case only is divisible by 3, we need to show. Okay. So let's do this. Question number 5. Let n is any positive integer that should be divisible by 3, right? So in the question they have given n, n plus 2 or n plus 4 is divisible by 3. Okay, and b is equal to 3 here. By Euclid's algorithm division lemma, n is equal to, here n we have taken, n is equal to bq plus r. That means we get same steps. N is equal to 3q plus r. So here r value is less than 3. That means r values are 0, 1, 2. Okay. Case 1 we'll see. Case 1 we take r value as a 0 and we will check for n value, n plus 2 value, n plus 4 value. Okay. First case 1, if r is equal to 0, then n is equal to what? 3q plus 0. See here, 3q plus 0 means what is this? R is, remainder is 0, right? That means n is divisible only by 3. If your remainder is 0, n is divisible by 3. Here, n is divisible by 3. Since r value is 0, remainder is 0. In this case only, add n plus 2 case also we need to check, right? N case we checked. N plus 2 and n plus 4 also we need to check. Add plus 2. Sorry, add means plus only, no? Add 2 on both sides of n. Both sides. So what do we get? N plus 2. For this I am going to add 2 is equal to 3q plus 2. See here. In the remainder place, what do we have? 2 we have. So here n plus 2 is not divisible by 3. Why? Since remainder we are getting 2. So it is not divisible. Until unless you get a 0, it is not divisible, right? Now we need to check n plus 4 case also. So now add 4 on both sides to the case n. So n plus 4 is equal to 3q plus 4. See, when we want to take out a 3 as a common factor, we can split this 3 plus 1 form, right? So which is nothing but 3 common means q plus 1 plus 1. So this is again 3m plus 1 means you are getting a remainder 1. Here n plus 4 is not divisible by 3 since the remainder is how much 1. This is case 1. Now case 2. Case 1 we substituted r value as a 0. Now case 2. If r is equal to 1, okay, then n is equal to 3q plus 1. What do we got here in the place of r1? So hence n is not divisible will by 3 since r value is 1. Now add 2 on both sides for this. So n plus 2 is equal to 3q plus 1 plus 2. So 3q plus 3. Let's take out 3 as a common factor. We get a q plus 1. So any remainder is there here? No, 0 remainder. So n plus 2 is divisible by 3. Why? Since remainder is 0 here. Okay. Now add plus 4 to the both sides. Plus 4. So 3q plus 5. Okay. So you can't take out a common, right? 3. So you split this with a 3. So now we can take out q plus 1 plus 2. This is like 2 is a remainder here. It is a multiple of 3, of course, plus 2 is a remainder. So n plus 4 is not divisible by 3. Since we got a remainder, something as a remainder 2. Okay. So now we need to find out case 3. What is case 3? If r is equal to 2, then n is equal to 3q plus 2. Okay. Here we got a remainder as a 2. So n is not divisible by 3 since remainder is 2 here. Now add plus 2 on both sides. N plus 2 is equal to 3q plus 2 plus 2. That means 3q plus 4. We can't take out a common, right? Split this as write this one as a 3 plus 1. Now let's take out a common q plus 1 plus 1. So again we are getting a remainder as a 1. Is it divisible? No. So n plus 2 is not divisible by 3 since remainder is 1 here. Last case, add 4 on both sides. N plus 4 is equal to 3q plus 3q plus 2 only, no, our remainder. 3q plus 2, for this remainder we are adding 4, right? Now, this is nothing but 3 cube plus 4 plus 2 is 6. What is common? 3 is common. Cube plus 2, 3 is 6. Do we get any reminder here? Nothing. This is like a 3m or 3p something with a reminder 0. Therefore, n plus 4 is divisible by 3 since reminder is 0. Let's observe these three cases. First case, here n is divisible by 3 since remainder is 0. In the second case, when r is equal to 1, n plus 2 is divisible by the 3. When third case, r is equal to 2, n plus 4 is divisible. N plus 4 is divisible. Okay. So, what you can conclude? One and only. So, one and only one out of n plus 2, n plus 4 is divisible by 3 when n is a positive integer. Let's conclude the statement. Therefore, one and only one out of n plus 2 or n plus 4 is divisible by 3. Okay, thank you. For more number of questions, keep watching my channel.